Hi students, this section is on solving compound inequalities. So when we're working with compound inequalities, you're going to see two different types of inequalities, working with the word and or working with the word or. When you're working with inequalities and you see the statement and, what that means is when you're graphing inequalities, you're going to set it up and write it where the inequality is going to join together and have the variable x be in the center. Whereas when you have a statement or within the inequalities, when you're looking at a number line, the situations are going to go in opposite direction. Something like this. So we're going to look at some examples here, working with and, or, and graphing it. So example number 1, it says write an inequality that represents the set of numbers and graph the inequality. Here it says all real numbers. Remember, all real numbers can be any number, so we'll call that a variable x. All real numbers that are greater than 0. So how would we write that? X is greater than 0. That's the way to write that. And here's the word and, less than or equal to 4. So an x is going to be less than or equal to 4. So how would we write that, thinking of combining that together? So x is greater than 0. So 0 is the lowest number here. So we're going to actually write it as 0 is less than x. That's another way of saying x is greater than 0. But then we also have to bring in this x is less than or equal to 4. So x we'll say is less than or equal to, that is the less than or equal to sign, less than or equal to 4. So this inequality right here represents the statement, so now we have to graph that. So let's set up our number line here. So we're starting at the number 0. X is greater than 0, so we're not including 0 here, so we'll have an open circle. And we're going all the way to the number 4, where x is less than or equal, so it can equal 4. So we'll have a closed-in circle at 4. And x is going to be any number here between 0, it does not include 0, and 4, but it could include 4. So this graph represents that statement in the inequality here. The next one says all real numbers, so that can be x, that are less than -1. So less than -1. Here we have or, so this is going to be two separate inequalities. Or x can be greater than 2. Notice this has and, the second statement has or, the statement or. So how do we graph this? X is less than -1. Well, let's draw our number line here. We have 0, 1, 2. So for the first situation, x is less than -1, we're going to have an open circle at -1. X is less than, so we're going to shade to the left. So x can be any number less than 1, does not include 1, or x is greater than 2. So we'll have an open circle at 2 and shade to the right. And so this is an or situation. Here we have an example working with the and, compound inequality with the statement and. So what they want us to do here is we have this inequality and they want us to solve it and then graph it. And you'll notice it's an and situation because it's going to come together here. So when we look at this, -5 is less than or equal to 2x plus 3. Which is less than 7. So the way I solve this is I'm first going to solve it in the terms of -5 is less than or equal to 2x plus 3. And then what I'm going to do is I'm going to solve it in the terms of 2x plus 3 is less than 7. So I'm going to solve it two separate situations here, and then you'll watch how it all graphs and comes together here. So first I'll solve it as -5 is less than or equal to 2x plus 3. We want to get that x all by itself. So we're going to subtract 3 to both sides. On the right side, it cancels. -5 plus 3 is going to give me -8, which is less than or equal to 2x. I want to solve for x, so I'm going to divide both sides by 2. We're dividing by a positive here, so it's going to be -8 divided by 2 gives me -4, which is less than or equal to x. So that's solving it the first half of this. I'll switch my colors here to blue. So now I'll solve it for 2x plus 3 is less than 7. I'll subtract 3 to both sides. So we get 2x is less than 4. Divide 2 to both sides. So x is less than 2. So now that I have this, we have -4 is less than or equal to x, and x is less than 2. So how can I write this as an and situation? Well, my final answer is going to be written like this. -4 is less than or equal to x, and x is less than 2. So now let's graph this. We can create our number line. So we're starting at -4, and it's saying x is greater than or equal to, so it can include that -4, so I'll have a closed circle at -4. For up here, the highest number 2, it says x is less than 2, so it does not include the 2, so I'll have an open circle at 2. So x is going to be any number here between -4, which can include -4, and the number 2, but it does not include 2 right here. And this is my final answer with the graph that represents my situation. So I solved, I've showed my work, and I've graphed it. This is an and situation. Now let's solve an inequality working with the or statement, the or, where the two graphs go in opposite directions. So here we have solve and graph the compound inequality. We have 6x minus 5 is less than 7, or 8x plus 1 is greater than 25. So we're first going to solve this by solving 6x minus 5 is less than 7. So we're going to solve for x, so we're going to add 5 to both sides. So we have here 6x is less than 12. Divide 6 to both sides. So we get x is less than 12 divided by 6 is 2. So I've solved the first one. Now I'll solve the second one. That 8x plus 1 is greater than 25. I'll subtract 1 to both sides. So we have 8x is greater than 24. Divide 8 to both sides. So x is greater than 24 divided by 8 gives me 3. So we can say x is less than 2, or x is greater than 3. So to write this, it would look like this. X is less than 2, or x is greater than 3. Now when we graph this, watch what happens. If we start 0, 3, 4, 5. So x is less than 2. I have an open circle at 2, and I shade this to the left. Or x is greater than 3. So I have an open circle at 3. I shade to the right. And x can be like this. So here's my answer, and the graph shows the or situation above as well. Last example here with number 4, it says solve and graph the following compound inequality. We have -2 is less than -2 minus x, which is less than 1. So let's solve this. Again, to go about solving this, we're going to solve the front half first. Then we'll solve the second part of this, which is that -2 minus x, which is less than 1. So let's solve for first. Negative 2 is less than negative 2 minus x. Whoops. I want to solve for x. Notice there's a negative in front of the x. We're going to have to make that become positive. So watch what happens here. We're going to add 2 to both sides. Negative 2 plus 2 becomes 0, which is less than negative x. You cannot have a negative variable, so remember there's a 1 in front of that negative sign. We can bring in a 1 here. We're going to divide both sides by negative 1. Here we're dividing by negative, so we do have to flip that inequality. So 0 divided by negative 1 just becomes 0, so it's 0 is greater than x. So that's solving the front half of this inequality, which is this part. Now let's solve the blue part, the second part of it. Negative 2 minus x is less than 1. Add 2 to both sides. So we have here negative x is less than 3. Again, we have a negative x. Think of a 1 in front of that x there. I want to get rid of that negative, so I'm going to divide both sides by negative 1. So we have x, we reverse the sign, is greater than negative 3. So what we have here, we read this as 0 is greater than x, and x is greater than negative 3. So if 0 is greater than x, 0 is greater than x, and x is greater than negative 3, the way we can write this is 0 is greater than x, and x is greater than negative 3. That's how we would write this. Now let's graph it. We have an open circle at 0. X is greater, 0 is greater than x, and x is greater than negative 3. So we also have an open circle at negative 3, and x is anything between 0 and negative 3. And that would represent my inequality, which that would be an and compound inequality situation right there.